Hi everyone, I am Alberto Rodríguez Ardila from Laboratório Nacional de Astrofísica in Brazil, and my contribution is based on results of a novel black hole mass scaling relation based on coronal lines and supported by accretion predictions. This work is done in collaboration of Almudena Prieto, Saya Pruta Panda, and Murilo Marinello. The spectral energy distribution of antigalactic nuclei, which extends from the radio up to gamma rays, cannot be directly observed from the Lyman limit up to a few hundred eV. This is because of the neutral hydrogen density column of our galaxy, as well as in the host galaxy of the AGN. The bulk of this energy is thought to be produced in the atmosphere of a geometrically thin, optically thick accretion disk around the supermassive black hole. Observations of quasars and photoionization equilibrium models suggest that this intrinsic continuum peaks somewhere between the UV and the X-rays. Its shape very close to that of a black body, with the maximum temperature representing the effective temperature of the accretion disk, where most of the energy of the accretion disk is radiated. Much effort has been done in order to unveil this continuum in AGNs. And in this respect, the coronal lines are optimal features to trace the shape of the ionizing continuum. This is because the ionization potential of these lines are in the 100-400 eV range, precisely in the region that we cannot observe the form of the ionizing continuum. And as we can see here in this plot, three different spectral energy distributions in full line for three different black hole masses, from 10 to the 6 to 10 to the 8 solar masses. The full lines represents the case of no spinning black hole, while the dotted lines are the equivalent for the case of a 10% spin black hole. We can see here that for these four lines employed, iron 7, silicon 6, sulfur 8, and silicon 10, the ionization potential of these lines fall precisely in the very close to the maximum of the distribution when the black hole is of the order of 10 to the 6 or 10 to the 6 or 10 to the 7 solar masses. So we want to test our hypothesis that these coronal lines are indeed photoionized by the intrinsic continuum emitted by the accretion disk. And to this purpose, here we relate the mass of the black hole of a sample of objects that were determined by reverberation mapping with the strength of the coronal lines normalized to the strength of the broad component of the hydrogen line for four different coronal lines as shown here: silicon 6, silicon 10, sulfur 8, and iron 7. And for the case of silicon 6, and the mass of the black hole, we found a very tight correlation that could be represented by this correlation here. And if for the other lines, the correlation is weak. But if this correlation is valid, we can use it as a way to weighting black hole masses in galaxies, because of this very tight correlation, very similar to that we can found in the MS sigma relationship already known for everybody. So we here use photoionization models in order to explain this very nice correlation. Here again, the open squares are the observations, and we make a grid of cloudy using as input continuum this form, which represents a modified black body with an underlying power law. And for the disk temperature, we use the disk prescription of Frank et al. That relates the temperature of the disk with the mass of the black hole, the accretion rate, and the radius of the accretion disk, as well as the efficiency of the accretion. So we use this prescription here, and we found here the best outputs that reproduce very nicely our observations. We found that from cloudy, that the clouds emitting silicon 6 should be located between 0.3 and 1 parsec, have densities between 10 to the 4 and 10 to the 6 cubic centimeters, and ionization parameter very close to about 0.25. So our takeaway message is that the coronal line emission in the central few particles of AGN is likely the result of photoionization by the continuum emitted by an accretion disk. And this result allows us to report a novel black hole mass scaling relation over almost 3 orders of magnitude in black hole mass, from 10 to the 6 to 10 to the 8 solar masses, and the strength of the coronal lines. The temperature of the accretion disk is the key parameter driving this correlation, and is offers an alternative for weighting black hole masses. So thank you very much.